Here's another rule that you can use for simplifying logarithms. It's very similar to the log of the product of two things, but this time it's for the log of the quotient. And it's related to this rule of exponents, that if I take 10 to the a divided by 10 to the b, what I do is I subtract exponents. I get 10 to the a minus b. And that gives rise to this logarithm rule, that the log base 10 of a quotient, log base 10 of x over y, is the log base 10 of x minus the log base 10 of y. That's provided x and y are greater than 0. Let's see how we can show this rule using this rule. We start with this side, we try to end up with this side. So we take log base 10 of x over y, and what we're going to do is we're going to write the x and the y as in terms of logarithms, using the fact that exponents and logarithms undo each other. So we replace that x right there with 10 to the log base 10x, because 10 to the log base 10x is the same as x. 10 and log base 10 undo each other. We replace that y right there with 10 to the log base 10y, because 10 to the log base 10y is just y, because 10 and log base 10 undo each other. So that log 10 stays the same. X is replaced by 10 to the log base 10x. Y is replaced by 10 to the log base 10y. Now look at this expression and compare this expression. It says if I have something of 10 to the a over 10 to the b, I can use this rule. Well, I've got 10 to the something and 10 to the something else, so I can use this rule. That is, a is going to be log base 10x, and b is going to be log base 10y. And I'm going to be able to simplify what's inside this log base 10 as 10 raised to the log base 10x, that was a, minus log base 10y, that was b. So that log base 10 is that log base 10. I've taken this ratio, applied this rule to get 10 to the log base 10x minus log base 10y. And so now look what I have. I've got log base 10 of 10 raised to 1 big power. But log base 10 of 10 to the anything, log base 10 and 10 to the anything, log base 10 and 10 undo each other. And I'm just left with this exponent, log base 10x minus log base 10y. And so what did I do? I started with log base 10x over y. That was this side. And I figured out it was equal to log base 10x minus log base 10y. That's this side. That's the proof of this. Let's see how it's used. Let's see if we can evaluate log base 10 of 2500 minus log base 10 of 25. Well, I have no idea what log base 10 of 2500 is. I have no idea what log base 10 of 25 is. It's a number. Who knows? But I could use this rule backwards and combine the two to see what I got. That is, I could use 2500 for x and 25 for y. So I can combine this difference of logs and say, going backwards here, this is log base 10 of 2500 over 25. Well, that's handy because 2500 over 25 simplifies to just 100. So I have log base 10 of 100. And log base 10 of 100 is easy to find because that's log base 10 of 10 squared. 100 is 10 squared. And log base 10 of 10 to the anything, well, that's just the anything, so I just end up with 2. So I can evaluate log base 10 of 2500 minus log base 10 of 25 using this rule of logarithms, and then simplifying it back to log base 10 of 10 to the something, and just ending up with 2. As another example, let's evaluate log base 10 of 1 over 10 to the 30. Well, we can use this rule. It's something divided by something else. So I can write this as log base 10 of 1 minus log base 10 of 30, going directly. Log base 10 of 1 we had figured out is 0, and log base 10 of 10 to the 30 is, of course, 30, because log base 10 of 10 to the anything is just that anything. Well, 0 minus 30 is just minus 30. So log base 10 of 1 over 10 to the 30 is just minus 30. So this is, again, another rule that you can use for simplifying logarithmic expressions, and it's a very powerful, very useful rule to know.